Hello there, these are video solutions for the day 4 packet problems. These went along with problem 1.4 that we did in class. So without further ado, day 4, problems 1.4. Number 20, use the dimensions of each rectangle that can be made from the given number of tiles to list all the factor pairs of each number. Okay, so they're really saying list the factor pairs of each number. We can do that. So you should have written, let's see, 12. I like to always start out saying 1 by 12, and then I like to go 2 times, well, 12 divided by 2 is 6, and then 3 times 4. Remember, each of these can be written as the other direction, but they're still the same factors. So 12 by 1, 6 by 2, 4 by 3. So really just one's fine. The number 24, so this is another number that's a composite number. So 1 by 24, 2 by 12, 3 by 8, and 4 by 6. So there's 4 factor pairs, or we could say there's 1, 2, 3, 4, 5, 6, 7, 8 factors. Last but not least, 32. We can say 1 by 32, 2 by 16, 4 by 8, 5, 6, 7, 8. I think we got them all. All right, so let's move on to the next problem. That was 21. What type of number has exactly 2 factors? So what type of number has 2 factors? Well, in class we've done a lot of work with prime numbers. We've done a lot of work with composite numbers and square numbers. So, which one of those has 2 factors? Well, let's just take a prime number. We said that 2 is the smallest even prime. So 2 would be 2 times 1. Let's put a composite number down, a number that has more than 2 factors. So we know it would be 1 times 4, 2 times 2. Well, 4 would also be a square number, so it'd be 1 by 4, 2 by 2. But let's go back to the question. It says which one has exactly 2 factors? Well, the one that has exactly 2 factors would be a prime number. So prime numbers have exactly 2 factors. Let's find another number that we know to have 2 factors. How about 3? So that would be 3 times 1, or 1 times 3. How about 7? 1 times 7, or 7 times 1. So prime numbers have 2 factors, and there's several examples. How many rectangles can you build with a prime number of square tiles? A prime number. Well, let's take a prime number. Let's take our favorite prime number from our game, which was 29. And we know that we can do a 1 by 29. So we have 2 factors. So how many rectangles can you build with a prime number? Well, 1 by 29 is the same as 29 by 1. So I'm just going to say 1. Or if you want to say 2, because you can spin it being vertical or horizontal, I guess that would be okay. But really it's just 1. 23, the Olympic photograph below inspired a school pep club to design a card display for football games. So you've seen that at games where they hold up certain sections of the stadium, hold up different color cards. In this case, it looks like they make flags. So each display uses 100 square cards. At a game, groups of 100 volunteers will hold up the cards to complete the pictures. They are most effective when the volunteers sit in a rectangular arrangement. What rectangular arrangements are possible? Which would you choose and why? All right, so this was like in class when I said you were going to the mall to have a stand to sell craft items. Well, the first thing you need to do is come up with all of the different rectangular arrangements. So to do that, we're trying to find what rectangular arrangements are possible. So we need to find the factors, the different factors of 100. So the different ways we can make 100. So let's do that. 1 by 100, 2 by 50, 4 by 25, 5 by 20, and 10 by 10. So if you were at a game and looking at this flag right here, or the Britain flag, you probably wouldn't want a super long group of tiles, because it would look something like this. It would look, you'd have a whole bunch of people in a line, each holding a square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can't even get 100 on here, but you get the point. You wouldn't even be able to tell it was a flag. So I think the best choices for ones to choose, which one would you choose and why? I would say the best two choices would either be, I'll circle them in green, I think 5 by 20 or 10 by 10. The closer to a square, just as you see here in the pictures, these look pretty much like a square. The closer to a square, or even 5 by 20, more like a flag, those would be the two best that I could explain. Last one, a school band has 64 members. So I got 64 members. What rectangles can the band director make by arranging the band members? So you should have been thinking, okay, 64 is a composite number. Let's make all the different ways we can do 64. So let's see, let's make some 64s here. I like to start with 1 by 64. That would be weird. The band would be super long. 64 people in one long row. 2 times 32. So you'd have 32 by 2. That probably wouldn't be much better. 4 by 16. It's getting better. And then 8 by 8. Which is a square, because 64 is a square number. So these are the rectangles. These are the 4 rectangles you can make by, that's this one, and then an 8 by 8 is obviously a square. So those are the 4 rectangles you can make. I'm not sure which one the band director would choose. What do you think? So those are the solutions for day 4 problems.